Question number 4. Explain why this graph does not represent a function. To solve this question, we should know that if we have the sketch and if the sketch fulfill the vertical line test, BLT is vertical line test. If the sketch satisfy the vertical line test, then the sketch is the function. So you can say that if the sketch passes the vertical lines test, then the sketch is the function. Similarly, that sketch also passes the horizontal line test, then the function is one-to-one. So we can say that if the sketch passes the vertical line test, then it is a function, and if the sketch passes the horizontal line test also, then it is the one-to-one function. If the test does not passes the horizontal line test, then the function not have the will not have the inverse function. So the function which satisfy the vertical line test but not passes the horizontal line test, then the sketch is the one-to-many function, and that function will not have the inverse. To have the inverse function, a sketch should satisfy the vertical line test and horizontal line test both. Okay. Explain why this graph does not represent the function. Because when we draw a vertical line, this line intersects the sketch at 2 points. So we can say that this sketch or this graph have failed the vertical line test, so it is not the function. So we can say that because vertical line have more than one intersecting point. So that's why this graph is not the function. Part B, the table show the graph of 4 different functions. So these are functions, it means they satisfy the vertical line test. Okay, now we need to find whether it is one-to-one or many-to-one. So I just told you if line satisfies the horizontal line test, so it is one-to-one, otherwise it is many-to-one. So you can see that this line intersect at more than 1 point, so it failed the horizontal line test. So it is many-to-one. It is many-to-one, so its inverse will not be exist. So this one is cancel out. Now in this graph, if we draw a horizontal line, we can see that there is only one intersecting point. It means it passes the horizontal line test. So this function is one-to-one. Similarly, when we draw horizontal line here, we can see that this graph has more than one intersecting point, or you can say that there are 4 intersecting points. So we can say that this graph is many-to-one. Similarly, if we draw a line, there is only one intersecting point, so it passes the horizontal line test, so this one is one-to-one. Now how we can know that the function is itself is the inverse function? We can see that only one-to-one function will have the inverse function, and if the function is one-to-one, so it will have the inverse function, and function which is its own inverse should have the y-intercept and x-intercept equals. For example, in this case, this is the y-intercept and this one is the x-intercept. So when we find the inverse, x-intercept become y-intercept and y-intercept become x-intercept. So y-intercept and x-intercept are both 4, so it means this function will be its own inverse. Part C. Function f and g are defined as follow. Function f is sine of x, where x is less than or equal to a degree and greater than or equal to 30 degree. Where g of x is under root x minus half, or x is greater than or equal to half. It is given that the function g of x exists. Find the value of a so that the domain of g of x is as large as possible. You may use the information that sine of theta is equals to half. Okay. First we find the g of f. G of f is equal to g of f of x. G of f of x means sine of x, and when we plug sine of x in the function of g, we will have under root sine of x minus half. Okay. Now we need to know for what value of a we will have the maximum possible domain of g of f. First thing you should know that domain of g of f of x is equals to the domain of f of x. So in given condition, we have the domain of f of x, which is x is less than and equal to a naught and greater than and equal to 30. We need to find the value of a such that this domain will have the maximum span. Now we know that x is from 30 to a naught. If we plug the value of x is equal to 30, so g of f of 30 degree is equals to under root sine of 30 minus half, and we know that sine 30 given which is half, so it is under root half minus half, and this one is equal to 0. We can increase the value of x up to a degree, and what will be the a? If we plug 90 degree, so it will be under root 1 minus half, and this one is equal to under root half. Similarly, if we further increase the value of x, so we know that this is the sine, and sine is positive 0 to 180, but it should be greater than half so that we can have positive value of g of f. So we know that at 30 this is half, and when 90 it is 1. Now after 90, when we further increase the value of x from 90 degree, this is 90, the sign of x will decrease and it will reach half again, this value, at some angle, and this angle is equals to the 180 minus 30 degree, because sine of 30 is 90, so this one is 150 degree, so this one is 150. If we further increase the value of x after 150, the value of sine of x will be less than half, and when we plug the value of sine of x less than half, this value will become negative. So we can increase the value of a up to 150 degree. So we can say that a is 150 degree, and the domain of g of x will be x less than and equal to 150 and greater than and equal to 30 degree. Okay. For the domain found in part 1, find the range of the function g of f. We just calculated g of f is equals to the under root sine of x minus half. Now we just calculated the domain of g of x, which is 30 to 150, and we know that when we plug the value of 30 we get the value of 0. So we can say that g of f of x at 30 is equals to 0. Now what is the maximum value we can achieve when we plug x from 30 to 180? Because we know that sine 90 is 1, so we can say that maximum value we will achieve when g of f of 90 is equals to the under root sine of 90 minus half, and this one is equals to under root 1 minus half, and this one is equals to under root half. These two, which are minimum and maximum value, we can achieve when we plug these domains. So we can say that range of g of f of x is equals to the g of f of x is less than and equal to under root half and greater than and equal to 0. This is the range. Part 3, determine whether the function g square exists or not. We know that g square is equals to g of x. G of x is equals to the under root x minus half, and the domain of g of x is given, which is x is greater than and equal to half. For x is greater than equal to half, when we plug this value of x, so we will get the range of g of x, which is when we plug half, g of x is 0. So when we further increase value of x greater than half, we will get g of x greater than 0. So we can say that it will be up to infinity. This is the range of g of x. On the other side, this g square, which is equal to g of x, this is the range of g of x. So range of g of x is domain to the g of x, which is the domain of g of x. And we know that domain of g of x should be greater than and equal to half, but range of g of x is from greater than 0. We can say that this one is greater than and equal to 0. So we can say that range of g of x is not the subset of the domain of g of x. You can say that this one is the domain of g of x. This one is the range of g of x, and this is equals to the domain of g square. So we can say that g square does not exist because the domain of g of x is subset of the domain of g square, or you can say that range of the f of x. This function is not exist because range of g of x is not the subset of domain of g of x.